Hello, my name is Dlimi Zakariae and I will present my topic, a lightweight blockchain framework for IoT integration in smart city, prepared by myself and my supervisors, Mr. Ezzati, Abdellah and Mr. Ben Allah Saïd. The research is conducted in the LAVETE Laboratory of the Faculty of Science and Technology at Hassan First University of Settat. Our guide during this presentation will be introduction and motivation, related work, proposed framework, simulation, and finally conclusion. Smart City is a whole framework that enables cities to address these challenges with effective technological solutions like improvement of daily life, optimization of consumption, risk reduction, improving governance, creating and seizing new opportunity. The term IoT is defined in recent literature by objects with virtual identity and personality in an intelligent space, using interfaces to connect and communicate with social, medical, and environmental and user context. In Smart City, the IoT is a real accelerator for the development and success of smart cities, allowing it to migrate all components of the city to the digital world. However, with the IoT in Smart City, there will be a high number of connected objects reaching billions in 2020. They have limited storage autonomy computing capacity. They are industrialized and marketed by different suppliers. This leads to the following problems: bottlenecks, impossibility to implement security standards, problem of harmonization and standardization. On the other hand, the blockchain, a distributed registry system that records all history as a sequence of blocks, originally proposed and used for the implementation of Bitcoin. The data is duplicated and stored in the peer-to-peer network of the blockchain. Participating nodes adhere to consensus algorithm for policing, security, and resiliency. Like proof of work, some frameworks also support code executing to modify the state of the blockchain according to program clauses. This brings transparency, orchestration, security, and disintermediation. So, the blockchain technology integrated with IoT in Smart City can bring decentralization to avoid one-point failure problems, security and trust, platform as a bridge between different suppliers, autonomous orchestration. Some studies have addressed the opportunity of using blockchain in IoT context on smart transportation, smart home, smart healthcare, and smart agriculture. However, there are still open challenges for the integration of the blockchain with the IoT. We list the standard consensus of the blockchain proof of work is resource intensive due to its encryption and hash algorithm. The duplicate data register model is not suitable for the storage capacity of the connected objects. So our aim is improving the blockchain model to a lightweight framework suitable for IoT in Smart City. The architecture of our proposed model consists of two levels. One, the connected object of low capacity, and two, the blockchain network reserved for the connected objects which have capacities between medium and high. And we defined three roles for the participants in this architecture. One, think only, wallet only node, and validator node. Things only, which cannot participate to the blockchain but connected to other higher level objects. Wallet only node, which hosts the blockchain component application but decide not to participate in the data validation. And finally, validator node, which performs all the functionalities of the blockchain component application to maintain network compliance. In the node components, we find a blockchain app which composed of logic brick for control, consensus, and signature, security brick for key-pair, ledger which is data organized as a chain of block. We find also the most popular IoT interface, such as MQTT, CoAP, and REST API. And finally, the peer-to-peer channel to connect to the other nodes of the network. Now let's see the logic sequence. First, we start the node. The node creates Genesis block. IoT object send data to this node. This node creates and sign a new transaction and add this transaction to the pool. This node broadcasts this transaction to the other node. The other node verify and add the transaction to their pool. When the duration or size of the block is completed, the node starts the proof of work consensus. The first node who achieved the work creates a new block and added it to their local blockchain, and then broadcast the chain to the other node. The other node verify and replace their local chain. The conditions of the simulations are: the blockchain network is made up of 10 nodes. IoT thing only is simulated by a script shell which send data through a REST API interface. The nodes of the blockchain are T2 micro instance from Amazon Cloud Services with 1 GB in RAM and 1 CPU. It's a very low configuration similar to Raspbian P2. And finally, block validation triggered every 5 minutes. After presentation of the results, we see that for the block validation algorithm, RAM consumption remained at a comfortable level, not exceeding 12%, but CPU consumption, on the other hand, has exceeded the limits of the machine, requiring more from the cloud service configured in elastic mode, from 200 to 500%. And for the chain synchronization algorithm, the graphs show stable and low consumption of CPU and RAM. This is because of the low degree of complexity of synchronization function. Now, as a conclusion, in our current work, we proposed an initial lightweight blockchain framework to meet the constraints of IoT objects, and we implemented it to verify these limits with the proof of work consensus. The only implementation of blockchain with the Node.js framework is not sufficient with the proof of work based consensus and requires optimization at the level of the consensus mechanism. Thank you for your attention.